The fuel flows through a spar. This module describes the engine fuel system. Fuel is supplied by fuel pumps located in the fuel tanks. The fuel flows through a spar fuel valve located in the main tank. It then passes through the first stage engine fuel pump, where additional pressure is added. A second stage engine fuel pump adds more pressure before the fuel reaches the fuel control unit. The fuel flows through a fuel oil heat exchanger, where it is preheated. A fuel filter removes contaminants. The fuel is then controlled to meet the existing thrust requirements. The fuel then flows through the engine fuel valve and fuel flow meter before entering the engine. The engine fuel control system incorporates a fuel metering unit which operates in conjunction with the electronic engine control, or EEC. The fuel control system schedules fuel flow to meet engine thrust requirements as dictated by the thrust lever position and the specific engine operating conditions. The EEC controls the metered fuel and prevents engine limits from being exceeded. The motor-operated spar and engine fuel valves allow fuel flow to the engine when both valves are open. The valves open when the engine fire switch is in and the fuel control switch is in the run position. Both valves close when either the fuel control switch is in cutoff or the engine fire switch is out. The engine valve and spar valve lights illuminate momentarily as the valves open or close. You should monitor these lights to ensure proper operation during engine start and shutdown. If a valve position does not agree with the respective fuel control switch or fire switch position after allowing for the normal transit time, the light remains illuminated and the ICAS advisory message of left or right fuel spar valve or left or right engine fuel valve displays as appropriate. The fuel is filtered by a filter with bypass capabilities. If the filter becomes clogged with contaminants, fuel will bypass the filter, allowing contaminated fuel to enter the fuel metering unit. The ICAS advisory message left or right engine fuel filter displays to indicate the affected fuel filter is approaching a level sufficient to cause filter bypass. Erratic engine operation and flameout may occur due to fuel contamination. Fuel flow is measured after passing through the engine fuel valve. Fuel flow is displayed on the secondary engine display. Fuel flow information is also provided to the Flight Management System, or FMS, to be used in calculations for engine fuel burn during flight. Next, to answer some questions. Tanks, their fuel pumps, and check valves. We will now look at the three fuel tanks, their fuel pumps, and check valves. The main tanks contain two AC electric pumps. One pump is capable of supplying adequate fuel pressure to one engine for all thrust conditions. Normally, two pumps are used to provide fuel pressure to the respective engine. The two pumps in the main tanks are referred to as forward and aft pumps. Each pump has a low-pressure sensing switch located on the output side of the pump. When the fuel in a main tank is depleted and there is no more fuel to pump, or when the pump switch is selected off, the pressure switch activates a low-pressure light labeled PRESS in the associated fuel pump switch. A corresponding advisory message, such as right forward fuel pump, is also displayed on ICAS. The center tank also has two AC electrical pumps installed. These are designated as left and right pumps. The operation of these pumps is somewhat different from the main tank pumps. To reduce electrical loads, the center tank pumps are inhibited when the associated N2 is less than 50% RPM. Thus, both center tank pumps are inhibited when the engines are shut down. As an engine is started and N2 RPM increases above 50%, the inhibit is removed for the associated center tank pump. Therefore, before engine start, with the center tank fuel pump switches selected on, these switches will show both the on light with flow bar in view as well as the low pressure light. The two center tank fuel pumps have greater output pressure than the left and right main tank fuel pumps. When all 6 pumps are operating, the center tank pumps override the left and right main tank pumps so that center tank fuel is used before left or right main tank fuel. Note: there is an exception to the center tank pump's inhibit with N2 RPM less than 50%, and that is when the fueling station door is open. With the fueling station door open, the pump inhibit is removed, so that, with the engine shut down, these pumps can function and can be used to pump fuel out of the center tank. Normally, the center tank fuel is used first. When center tank fuel is depleted, the center pump low press lights illuminate, and the ICAS center left fuel pump and center right fuel pump advisory messages are displayed. Selecting the center tank pump switches to off extinguishes the lights and messages. The lights and ICAS messages are inhibited with the center tank pump switches off, because operation with an empty center tank is normal. The left main tank also contains a DC fuel pump, which is used exclusively for the APU when no AC pumps are operating. This pump has no controls or indicators in the cockpit and is totally automatic. Notice that the output of the DC pump is separated from the left engine fuel manifold by a check valve, restricting its output to the APU. The operation of the DC fuel pump depends on AC power availability when the APU is started or is running. If AC power is available, then the forward AC fuel pump in the left main tank automatically activates at APU start, even if its switch is not on. In this case, the DC fuel pump is not used. When the AC pump is operating, fuel from the left engine fuel manifold enters the APU fuel manifold through the check valve between the two manifolds. However, if AC power is not available when the APU is started or running, the DC pump will automatically operate. With only battery power available when the APU is started, the DC fuel pump is activated when the APU switch is selected to start. A small quantity of fuel remains in the center tank after display of the ICAS advisory messages Center Left Fuel Pump and Center Right Fuel Pump. A scavenge system will operate automatically to transfer any remaining center tank fuel to the main tanks. Fuel scavenge begins when the main tanks are approximately half empty. The center tank does not have any bypass valves. Hence, without AC electrical power for the center tank pumps, center tank fuel remains trapped in the tank. The cross-feed manifold interconnects the engine fuel manifolds and makes it possible for any AC-powered fuel pump to supply fuel to either engine or the APU. The manifold has one cross-feed valve, which isolates the left fuel manifold from the right manifold. Note: some aircraft have two cross-feed valves. The crossfeed valve is normally closed and is opened only to correct a fuel imbalance between the left and right main tanks or to feed an engine from the opposite tank. If a crossfeed valve does not agree with its switch position, the switch valve light will illuminate and a corresponding ICAS advisory message of Fuel Crossfeed is also displayed. On aircraft with two crossfeed valves, the associated ICAS advisory message is Forward Fuel Crossfeed or Aft Fuel Crossfeed. The fuel config light located on the fuel panel will come on, and an ICAS advisory message of Fuel Configuration will be displayed for three conditions. The first two are when the fuel quantity in left and right main tanks differ by 2,000 pounds plus or minus 500 pounds, or center fuel pump switches are off with more than 1,200 pounds in the center tank. The third condition for the fuel config light to illuminate is when the ICAS caution message Low Fuel is displayed. The NGS converts bleed air to nitrogen-enriched air, NEA, during all phases of flight. The NEA is delivered to the center fuel tank to reduce flammability of the tank. The operation of the NGS is transparent to the flight crew. It does not require any flight crew action to operate the system, nor are there any flight deck indications. The NGS automatically starts operating after takeoff and runs continuously through climb, cruise, descent, landing, and during taxi for a short period of time. The NGS shuts down after a specified period of time or when bleed pressure is no longer available.
A small quantity of fuel remains in the center tank after illumination of the center fuel pump low-pressure lights. A scavenge system is installed in the center tank that uses main tank boost pump output pressure through a jet pump to transfer fuel back into the main tanks. The system operates automatically when the main tank boost pump is operating and the main tank quantity is approximately 60% or less.
This module provides a short description of the refuel system. The three fuel tanks are pressure-fueled from a single fueling station located on the left wing. All fueling operations are normally accomplished from this point. When the fueling panel access door is opened, DC power from the ground handling bus is applied to the fueling system, and the operating inhibit of the center fuel tank pumps is removed. The fueling system uses a fueling manifold with three fueling valves, one for each tank. The fueling valves are controlled by switches located on the fueling panel. On this frame, we have colored the fueling valves and their associated panel switches. Individual tank quantities can be pre-selected via the load select controls. The fueling valves close automatically when the pre-selected quantity is reached or when the tank is full. You can click the 6 steps on the right side to highlight the associated switches. If any tank overfills, causing fuel to enter the surge tanks, all fueling valves are signaled to close to prevent fuel spillage. Additionally, you should know that the main tanks may also be filled through overwing fill ports. A defueling valve is provided to enable defueling of the tanks using either the tank fuel pumps or fuel truck suction. Note: fuel truck suction is not possible for defueling the center tank. Next, to answer some questions.
Each tank is equipped with fuel quantity probes. The probes provide data to a processor. The fuel quantity panel displays individual fuel tank quantities as derived from the fuel quantity processor. The processor corrects individual tank volumes for density. A separate calculation is used for the total fuel quantity indicator and is also provided to the FMC. The FMC provides a display of sensed fuel quantity before engine start and calculated quantity after engine start. Sensed fuel quantity accounts for APU fuel burn. Calculated quantity is the calculated engine burn using the fuel flow sensors subtracted from the quantity sensed at engine start. Therefore, discrepancies between fuel quantity displayed on the gauges and FMC displayed fuel quantity should be investigated by the crew. The fuel quantity panel also shows the fuel temperature of the left main tank. A blank indication for any tank and in the totalizer indicates no power or a failure of the quantity sensing system.
System that provides a method to jettison. The Boeing 767-300 has a fuel jettison system that provides a method to jettison fuel from the center tank. Jettison nozzles are located just inside of each outboard aileron. Note: it is possible to jettison all center tank fuel and still be over the published maximum landing weight. Two dual pump units in the center tank provide the force to jettison the fuel through a common manifold. The high-capacity pumps will jettison fuel at a rate of approximately 2,600 pounds per minute. For jettison, it will take approximately 30 minutes to empty a full center tank. The fuel jettison panel is shown here. To jettison fuel, the fuel jettison switch is first selected to on. This opens the jettison transfer valves and causes the jettison pumps to operate. The left and right nozzle switches are then selected on to cause the nozzle valves to open. After the center tank is emptied, complete the jettison procedure and turn off the center tank fuel pump switches when the pressure lights or ICAS fuel pump messages come on. The ICAS message, fuel jettison nozzle, and the left or right nozzle valve light illuminate if a nozzle valve disagrees with the commanded position, or one or both fuel nozzle valves are open while the aircraft is on the ground. An ICAS message of left or right fuel jet pump appears, and the fault light on this panel illuminates if the associated fuel jettison pump is inoperative. An ICAS message of left or right jettison transfer valve appears, and the fault light on this panel illuminates if the position of the jettison transfer valves disagrees with the selected switch position. The valves should be closed when the switch is off and should be open when the switch is on. Next, to answer some questions.